Today we'll be talking about the halogens. This topic is theme 11.4b. I think we're by now, through our study in classes 7, 8, 9, that you are familiar with the family called the halogens. We'll look at a little bit closer detail, however, of this family and the chemistry of this family during this theme. The assessment criteria for the halogens is understand and be able to account for electronegativity and boiling point trends as well as oxidizing ability trends, recognize the displacement reaction of the halogens, be able to identify halide ions using silver nitrate and ammonia, know the formation of chlorine water, and to discuss briefly the use of chlorine as a water treatment. Let's look at some of the trends in the halogens. On the bottom of the table, on the bottom of this slide, you'll see a table. It talks about ionization energy, electron affinity, ionic radius, and density. What do you see as you look at that table below? You can see that the electronegativity, the ability to attract or want electrons, goes down. The oxidizing ability also goes down, as well as the ionization energy, electron affinity, ionic radius goes up because of the increasing number of energy levels, and the density also goes up. You should be able to look at these tables and make predictions why this happens. We'll talk more about this in class. The following video will give you some ideas for the reasons for these trends. Halogens have the ability to displace or take the place of other halogens. This happens when they are competing to be combined with a metal. It is always the more reactive halogen that will win and become a part of the compound. The less reactive halogen remains in its elemental state. We can often tell which halogen we're going to get, or that we have gotten, from the color of the solution that we get. For example, if we add silver and chlorine, we get a white precipitate. If we add silver and bromine, we get a pale yellow precipitate. And if we add silver and iodine, we get a yellow precipitate. Now, these can be observed simply by color. We can further determine if they're chloride, bromide, or iodide by their amount of reactivity. Notice chlorine will dissolve that precipitate or in ammonia solution. It partially dissolves when you add to that pale yellow precipitate ammonia, and when you have iodine and you add ammonia solution, the precipitate does not dissolve. There is a whole study in chemistry of chlorine chemistry, and we can look at the formation of chlorine and its reaction with sodium hydroxide as part of that additional study in chemistry of the reactions of chlorine. You can see what happens when chlorine is added to water. You get hydrochloric acid, as you would assume, but you also get hypochlorous acid. And over time, we can have the hydrochlorous acid partially dissociate, and it will go to hydrogen and hypochlorite ions. And then we can further have a change in the hypochlorite ion to both chlorine ions and chlorate ions. Again, this is an entire area of science called chlorine chemistry. Similar things happen when we add a base. When we add a base, we create NaOCl, bleach, plus salt, plus water. This can often be used with a reaction that would like to remove chlorine gas as a product. You mix chlorine gas as with NaOH, and you can create salt and bleach. So for reactions that use chlorine, you have the ability to make other compounds from the chlorine that's left over. This is a picture of how chlorine can be used as a water treatment. You can see that chlorine is added in the later portions of the water treatment process. And we will discuss in class each of these steps in water treatment. There are benefits and there are risks to using chlorine as a water treatment. Chlorine addition can be as easy as turning a knob. You'll see how rather than having a water treatment plant in more developed nations, we can chlorinate water very simply.
billion people lack convenient, affordable options to provide safe drinking water for their families. The water they collect may be contaminated and cause illness or even death, especially in children. But a simple new water treatment system, a communal chlorine dispenser, can change that. Developed by Innovations for Poverty Action, an NGO that creates solutions to development problems, the chlorine dispenser lets people disinfect water, combining daily water collection and treatment into a simple one-step process.
Hiyo dispenser ambayo imewekwa kwa area yangu imesaidia watu kwa kuwaokoa na magonjwa ya maji, yani magonjwa ya tumbo.
Chlorine cleans dirty water at the source and protects against new germs for up to 24 hours.
A very tiny amount is enough to really kill off all of the germs in the water and to keep killing the germs in the water.
Using the dispenser is easy. The plastic tank and dosing valve are secured into the ground next to the water source. Users just turn the valve to release a metered dose of chlorine into the water they collect. As they transport water home, the chlorine begins to disinfect.
It's just like getting chlorinated water out of our taps at home. Dispensing chlorine in bulk is cheaper than almost anything else that's out there. It's about a third the cost of buying chlorine at stores. It's about 1/10 the cost of a borehole. Where we've installed it in Kenya, take-up has been 60%, which is really remarkable in this space where it's been hard to find technologies people want to use.
Dispensers can be assembled by local businesses and used by small-scale entrepreneurs.
Wateja wanafurahia kuja hapa kwa sababu tuko na dawa ya chlorine.
We put a drop of the chlorine in their buckets, then they draw water, it mixes and it protects them from getting waterborne diseases.
Chlorine as a water treatment has had varying levels of acceptance. It is widely accepted in the United States. Worldwide, it is not widely accepted because worldwide, the EU and other organizations see that the problems with chlorine as a water treatment, when it cannot be regulated, are worse than the benefits. Here are some questions to start your thinking. Again, you should complete these questions if you have not passed all the objectives on the first formative.